Hello everyone and welcome to a new video. Today we are going to learn the topic properties of rational numbers. So which properties we are going to learn? We are going to learn today the closure, commutative, associative and distributive property of rational numbers. The other properties I have covered in a separate video, which is additive identity, multiplicative identity, etc. So that you can check out in the other video so that the video does not become long. So before continuing, I would request you to kindly subscribe to my YouTube channel. If you've not done yet, please do not forget to press the bell icon. Besides that, you're going to find a few links. Make sure you join the Telegram group because that's the place where I give all the updates. So on this note, let's move ahead and start with the properties. Before that, a quick recap of the number system. So what are natural numbers over here? Natural numbers are a set of numbers from 1 to 3. Then what are whole numbers? Whole numbers are a set of numbers which include all natural numbers including a 0. What are integers? Integers are all numbers which include whole numbers but they include negative numbers too. And finally, rational numbers are all integers which can be expressed in the form a and b, where b is not 0, that is the denominator is not 0. So now that we are clear about the concepts, let's move to the first property, which is the closure property for rational numbers. So what does this property say? The closure property states that when you perform an operation such as addition, subtraction or multiplication on any two rational numbers, the result will also be a rational number. So let's check out a few examples. So addition, so you can see half plus 1 upon 3. So when you solve this out, you get I'm sorry, there was a disturbance, the urgent phone call to attend. So here the addition property, when you solve this half plus 1 upon 3, you get 5 upon 6, which is a rational number. Hence you would call that this is closed for addition. Next we move on to subtraction. Subtraction, you have 3 upon 4 minus 1 upon 2. So when you solve this, you're going to get 1 upon 4, which is again closed for subtraction. Let's check out the multiplication. We have 2 upon 3 into 3 upon 4, which you are going to get as half, which is again a rational number. Hence you're going to call it closed for multiplication. Finally, let's check out the division property over here. So division, 2 upon 3 over here. So like if you divide by 0, you can see it's not defined, hence it is not closed. So sometimes it can be or sometimes it cannot be, like in case over here when it's divided by 0, so it not defined or not closed. Next we move on to the commutative property for rational numbers. What is commutative property? Commutative property states that the order in which you add or multiply two rational numbers does not change the result. So let's check out the example. So first is addition. A plus b is b plus a. So here are the set of rational numbers we have taken. So you have half plus 2 upon 3, and what you have done, you have interchanged the order. So you have 2 plus 3 upon half. So when you solve it, you will get what? 3 plus 4 upon 6 on the LHS and 4 plus 3 upon 6 on the RHS, which is 7 by 6 on both sides. So you can see that LHS is equals to RHS, hence you call this property true for addition for rational numbers, commutative property. Next we move on to subtraction. A minus b is b minus a. So let's check this example. 3 upon 4 minus half and half minus 3 upon 4 on the RHS. So when you solve this further, you'll have 6 plus 4 divided by 8 on the LHS, on 4 minus 6 upon 8 on the RHS. So 10 upon 8, which is not equal to 2 upon 8. Of course you can divide it further and you get 5 upon 4 and negative 1 upon 4. So both are not equal, so hence it is not true for, or it does not validate the commutative property for subtraction. Then we have multiplication. A into b is b into a. So 2 upon 3 into 3 upon 4, and you reverse the order, 3 upon 4 into 2 by 3. So the answer you get is over here is these 3 and 3 are going to cancel. So you have 2 upon 4 on the LHS, 2 upon 4 on the RHS. Again it can be expressed as half. 1 upon 2 is equals to half 1 upon 2, but both are matching, hence you're going to call it true for multiplication. Finally, the division, a divided by b and b divided by a. So you have 2 divided by 3 divided by 3 divided by 4, and on the LHS, and 3 upon 4 divided by 2 upon 3 on the RHS. So 2 divided by 3 and divided by 3 upon 4, basically you're going to inverse and multiply. So multiply by 4 by 3, likewise over here 3 upon 4 multiply by 3 upon 2. So you'll have the equation over here 8 upon 9, which is not equals to 9 upon 8. Since LHS and RHS are both not the same, this property also does not hold good for division. Next, we'll move on to the associative property for rational numbers. So what does the associative property state? The associative property states that the way in which numbers are grouped in addition or multiplication does not change their sum or product. So basically we have seen a commutative property, grouping of, interchanging two positions, and here we are going to talk about grouping of numbers. So let's say check out the addition first. So you have a plus b plus c is equals to a plus b plus c on the LHS and RHS. You have group b plus c over here and a plus b over here. Let's try the same with a few examples. So you have half plus 1 upon 3 plus 1 upon 4, and same way over here, but you're going to group 1 upon 3 plus 1 upon 4 on the LHS and half plus 1 upon 3 on the RHS. As usual, we use BOD mass. You sort out the bracket first, so you'll have half plus 7 upon 2 on the LHS and 5 upon 6 plus 1 upon 4 in the RHS. When you're going to solve this, you're going to get 13 upon 2 on the LHS and 13 upon 2 on the RHS. Both are the same. Hence, you call that the associative property holds good, or it is true for addition for rational numbers. Next, we move on to the subtraction. So a minus b minus c is equals to a minus b minus c. Here you are grouping b minus c and a minus b. Let's solve with examples. So you have 3 upon 4 minus half minus 1 upon 4 on both the sides, but you're going to group half minus 1 4 on the LHS and 3/4 minus half on the RHS. Solving the brackets first, again 3 upon 4 minus 1 upon 4, and on the RHS 1 upon 4 minus 1 upon 4. So the answer is half, which is not equal to 0. Hence this property does not hold associative property for rational numbers for subtraction. Then we move on to multiplication. So what is multiplication? A into b into c is equals to a into b into c. The grouping is between b and c and a into b. So let's check out the examples. So 2 upon 3 into 3 upon 4 plus 4 upon 5 on both the sides. The grouping is of 3 upon 4 and 4 by 5 on the LHS and 2 by 3 and 3 by 4 on the RHS. So when you're going to solve the bracket first, you're going to get 2 upon 3 into 3 upon 5 on the LHS, and on the RHS you get half into 4 upon 5. When you solve it down further, you get 2 upon 5, which is equal to 2 upon 5. LHS and RHS both are same. So the associative property holds good for rational numbers for multiplication. Finally, you check out for division. A divided by b divided by c on the LHS, similarly on the right hand side, but the grouping is between b and c and a and b. Let's check out an example. 2 upon 3 into 3 upon 4 divided by 4 by 5 on the LHS, and on the RHS you group 3 upon 4 and 4 upon 5 on the LHS, and 2 upon 3 and 3 upon 4 on the RHS. So when you solve the bracket first, you get 2 upon 3 divided by 3 upon 4, and you see over here you're going to inverse and multiply, so this becomes multiplication and 5 by 4, and on the RHS you have 2 by 3 into 4 by 3, again inverse and multiply. So when you solve this further over here, you're going to get 2 upon 3 divided by 15 upon 16 on the LHS and 8 upon 9 on the RHS divided by 4 by 5. So when you solve it further, you get what? 2 by 3 inverse and multiply, it's 16 upon 5, which is not equals to 8 by 9 multiplied by 5 upon 4. So again you can see the final, when you sort it out, you have 32 upon 45, which is not equal to 10 upon 6. So the rational for rational number, the division also does not hold true. The associative property does not hold true for division. So finally move on to the distributive property for rational number. What does the distributive property state? That multiplication distributes over addition or subtraction. So multiplication over addition, first a into b plus c is equals to a into b plus a into c. So how it distributes? A into b, which is here, plus the plus sign in between, and a into c. Let's solve an example. You have half into 1 upon 3 plus 1 upon 4, that is half. So on the LHS, so what you're going to do? Half into 1 upon 3, which is here, the plus sign over here, and half into 1 upon 4, which is on the RHS. Now we are going to solve both the LHS and the RHS. So here, solving the bracket first, you have half into 7 upon 12, in the RHS you have 1 upon 6 and 1 upon 8 over here. Then when you solve it down further, you have 7 upon 24 is equals to 14 upon 48. So 7 upon 24 is equal to 7 upon 24 when you simplify it down further. So LHS and RHS both are matching over here. So the distributive property holds good for multiplication over addition. Let's check out multiplication over subtraction. A into B minus C is equals to A into B minus A into C. How does it happen? So you have A into B on the over here, negative sign in between comes over here, and A into C. So the multiplication distributes over subtraction. So let's take this example over here, half into 2 upon 3 minus 1 upon 3. So what's going to happen on the LHS? You're going to have half into 2 upon 3, which is over here, negative sign in between, and half into 1 upon 3. You solve the brackets first, so you'll have half into 1 upon 3, and in the RHS you'll have 1 upon 3 over here minus 1 upon 6 of this. So on the LHS you have 1 upon 6 is 3 upon 18, simplified down further, 1 upon 6 is 1 upon 6, which is true. So hence you're going to say that distributive property, for distributive property, multiplication holds good over subtraction. So finally here in the tabular form, the properties of natural numbers. So you can see that for addition and for multiplication, it is close, or it holds good for all the properties: closure, commutative, associative, and distributives in case of rational numbers. So I hope that you like this particular video. It's given you clarity. To let me know your feedback in the comment section. And before winding up, humble request, if you have not yet subscribed to the YouTube channel, I would request you to kindly do so now. Please do share this video. Until the next video, take care and be safe.